Today we're going to go over the data structure that allows you to store multiple pieces of data in a single variable. Hey, Code Operative here, helping you reach further faster in the programming world. If this is our first time meeting, welcome to the channel. The Code Operative channel is for developers of any level. This is a resource that will help you be confident in your skills and solutions. If that sounds appealing to you, hit the subscribe button, the bell, and keep watching to build those programming muscles every day. So we've gone over basic data types like integers, characters, floats, shorts, bytes, all that jazz. Today we're going to go over something called an array. So an array is a way to store multiple values in a single variable. Before we were just using a single variable to store a single value, but now you know there is a way to store multiple values in a single variable, an array. So array is a group of variables of the same data type. So say we have int lottery array, right? So here we've declared it. So we have int array lottery declared, and now we can assign it by going lottery equals new int of size 6. Okay. So now what this looks like, lottery looks like this. You have lottery, and it looks like so we have 6 variables stored in lottery, and they're all set to 0 currently. So if we wanted to set those, we can go, lottery 0 equals 15. And lottery 1 equals 6. And lottery 2 equals 68. And lottery 3, and so on. And then we have lottery 4 equals 41, and the Powerball number is going to be 2. So now our lottery array is going to look something like this. $15, $6, $68, $26, $41, $2. So you'll notice that the index positions are 0 through 5. Well, that's weird. We said the size of the array is 6. Well, that is 6 numbers. It's just that the array starts at 0. All arrays start at 0 in Java. So the benefit of something like this is you can create a loop. So you could go something like for int I equals 0, I less than lottery dot length I plus plus And then in here, do something like system out print line. Then we'll do number int plus, let's move this over just a tad. Lottery. I. Let's move that back. And with this little thing that we've created, this will print out all of our lottery numbers. So instead of having to say specifically, hey, print out lottery 0, print out lottery 1, print out lottery 2, we can just say print out lottery at position I, and then loop through all of the positions. So even if we increase the size of lottery, we don't have to change anything in the for loop, which is great. So what's interesting is an array is actually a pointer to a piece of memory. So it's a pointer to a piece of memory. So what does this mean? Well, if you imagine your memory, right, you have all this memory. You have 0x001, 0x002, 0x003, and so on. And over here it's like 0x ff2, something like that. Well, an array, in this case lottery, is pointing to one of these memory addresses. And this memory address holds one piece of data. So our 0th position held the value 15. And then our next position held the value 6, I think. What else do we have? 68, 26, 41. Right, so lottery is only pointing to the first piece of information. And then internally, it also has a member variable, internal variable called length, which tells you how big of a memory block this is referring to. So you could have other stuff in the nearby memory addresses, right? Maybe this is a B, this is an X, this is 22, whatever. But now you know that lottery is referring to this specific point. So I'm going to show you a different way to initialize an array. We'll make a lottery 2, right? And we don't have to set the size because we're going to initialize the values right off the bat. So we're going to give it the same values. Right. So 15, 6, 68, 26, 41, and 2. So this has the same values as the other lottery. So if we said, lottery equals lottery 2, values are the same, right? It should equivocate to the same value. Well, it won't. Because lottery 2, while it has the same values, is pointing to a different memory address, right? So this is where lottery 1 is pointing. And this is where lottery 2 is pointing. So this would be like 0x23, and this could be 0xF7, right? 0x23 is not equal to 0xF7. That's what it's actually comparing. So if you wanted to compare these two arrays, first you would have to do a number of comparisons, right? Is lottery.length equal to lottery2.length? And this comparison would work because these are primitives, right? So it's comparing strictly the value of the length. So say the length is equal, then you would continue on with something like for int I equals 0, I less than lottery length. And then above this we would have some value like Boolean is match equal to true. And then in this for loop, we could say if lottery I is not equal to lottery 2 I, then is match equals false. Right, and then if is match is true at the end, then they're the same. So you could do all this work to check to see if they're equal, or you can use the built-in library, arrays dot equals, and then just pass in a lottery and lottery 2. And then if it returns true, then the contents are equal. An interesting thing about arrays is that they don't have to be a single dimension, right? If you wanted, you could have another variable. We'll call this one lottery 3. Or let's call this one lottery group. Okay. And we're going to initialize this to be a group of lottery selections. So you do this outer curly brace, and then you do another curly brace, right? So our first number selections are 15, 6, 68, all that stuff. So let me zoom out so that I can see those. All right, so we have 15, 6, 68, 26, 41, and 2. So that's our first selection. And then we'll do another selection of, let's say, 65, 35, 45, 46, 47, 1. And then we can even do another one. So let's do another selection. And we'll say this one is 5, 6, 7, 13, 62, 63. Oh, actually we can't do that. The last number has to be less than 26. So let's make this one 25. Okay. So now we have 3 lottery selections in this lottery group array, right? We have one at the top here, one right next to it, and the bottom one. So this is like 3 arrays in one array. It's an array of arrays. So you can see even when I declared it that I put 2 square brackets. That means that it's a 2-dimensional array, right? There's multiple dimensions. So just a way to visually see how this works. You could imagine it like, at, I'm not going to put the equals there because that's going to be confusing. We can say at position 0, you have an array that is 15, 6, 68, 26, 41, and 2. And then you have position 1, which is 65, 35, 45, 46, 47, 1. And then at position 2, you would have 5, 6, 7, 13, 62, and 25. So this array, the first dimension, has 3 positions, right? 0, 1, 2, and then the second dimension on these has 6 positions. 0, 1, 2, 3, 4, 5. So it's a little matrix. So if we draw it like a matrix, 0, 1, 2. And 0, 1, 2, 3, 4, 5. Let's give it a little bit more space. 4, 5, 0, 1, 2, 3, 4. We have 15, 6, 68, 26, 41, and 2. And then we have 65, 35, 45, 46, 47, 1. And then this one has 5, 6, 7, 13, 62, and 25. Looks like this. 25. All right. So, now, let's say we want to reference this one, this 45. So how would we do that? Well, we would do lottery group position 1, position 2, position 1, position 2, right? And that would reveal 45. Let's do another one. Say we wanted to get this 25, right? We would do lottery group position 2, position 5. Position 2, position 5. And that would be 25. This one's 45. Cool. So that's multi-dimensional arrays, and you can add as many dimensions as you feel is necessary. So what I showed you before about the equals, however, will not work with multi-dimensional arrays because it assumes that there are no inner arrays, right? This is an array of arrays. So if you want to compare multi-dimensional arrays, Java has something called deep equals. So if you do arrays dot deep equals and then you can compare lottery group and lottery group and lottery group 2. So that will be the deep comparison if you wanted to compare multi-dimensional arrays. All right, that's all I have on arrays. Okay, now you know the data structure arrays. You know how to loop through arrays. You know how to handle single-dimensional and multi-dimensional arrays. what kind of data they store, and you learned a little bit about computer memory. So, question of the day. What data structure are you most interested in learning about? Let me know in the comments below.